In this section, we're going to take a look at our consumption of energy, really how we transform our sources of energy into things that we use in our everyday lives. And of course, this crosses into a lot of different disciplines, economics. It crosses into, environmental engineering, and we really have to be careful, how we look at the analysis that's presented here, because a lot of the analysis is provided by data of different environmental studies. And of course, this is a physics course. So we're going to look at this in terms of what we know, and, how energy is converted from one type to the other, and how this, of course, impacts the way we use the energy to, oftentimes just produce work. So again, highly controversial. So I'll try to tread lightly into this, because this is political dynamite for some people, especially people who don't trust the science behind this. So let's get going and talk about this. Again, um, talking about the economic aspect of this, our economy unfortunately relies on cheap sources of energy. And not only do these energy sources have to be cheap, they have to be reliable, in that we should be able to obtain this energy without much disruption. And of course, we know that throughout the years, different different world events can really impact this, especially whenever there's unrest in the Middle East. But again, we are primarily based on fossil fuels. We get our energy to run our economy, to run our industry, to basically help our lives be a little bit easier by burning these fossil fuels. And of course, there is a cost to using any source of energy. And one of the unfortunate side effects of using fossil fuels has been the increase of carbon dioxide in the atmosphere, and thus a change to our climate. So, when we look at the fossil fuels that we use as a percentage of our total energy use, we can see throughout the world, it's still very much dominated by fossil fuels. Oil, petroleum is the greatest source of energy. Coal is still used in very high quantities. Natural gas has been increasing more than the other fossil fuels, but it still is a very large source. We can compare it to what many consider to be greener sources of energy. We see that they play a very small role still today, and we hope that we can boost their contribution. Now, again, our biggest concern has been, what we used to call global warming. Now we call climate change. Basically, we are affecting our own climate by increasing something called the greenhouse effect. Now, the greenhouse effect is not something that is, good or bad. Actually, in terms of life, I guess we have to say that the greenhouse effect is good, because without the greenhouse effect, the climate on Earth would not be very conducive to life. In fact, there are times when the Earth was almost completely frozen over because of the lack of greenhouse gases in the atmosphere. So the greenhouse effect helps increase the overall average temperatures on the Earth by essentially trapping energy, trapping heat near the surface. The problem is not that we're trapping heat near the Earth's surface. In fact, there were times when the Earth was much warmer than it is today, and there were more greenhouse gases in the atmosphere. It is the rate at which we're changing the climate temperatures that makes it difficult for our environment to adapt. So that's really the big problem, not necessarily how much greenhouse gases are in the atmosphere, but at the rate at which we're changing it, which our environment cannot change with these changing global temperatures. Now, of course, there have been many people who have, presented their so-called studies that say that, the greenhouse effect has not been changed very much by human activity, but I think most of these have really been debunked. When we look at how human activity has affected our climate, it's very clear that we are playing a role. You can argue that to what degree we play a role, depends on how we analyze the data. And we do need much better climate models to talk about, how it is changing. But again, one of the biggest contributors to our change in climate, of course, is the burning of fossil fuels, which releases carbon dioxide. Also, the release of methane into the atmosphere, which can be a byproduct of extracting fossil fuels from the Earth's interior, or actually, below the ground. And of course, another problem that we're running into is as we heat the Earth up, more and more methane is being released from natural sources, as well as more carbon dioxide. So again, if you add up all the positive radiative forcing components, these are basically things that are causing our environment to get warmer due to more fossil fuel consumption. And the negatives, we get a net positive effect that, of course, is led to an increase in climate change. Now, one of the biggest challenges we have in terms of the political will to reduce our emissions is that we can't just do this locally. This has to be done over the entire globe. And the largest producers of carbon dioxide are, of course, China, the United States, India, and Russia, where we have some of the largest economies. And anytime that you make energy more expensive, the economy is going to suffer. And we can't just, drop the use of these as sources of energy and expect it not to have a drastic impact on, human human well-being, really. So again, if we look at how our climate has been changing, we can clearly see that as time goes by, the temperature does wander back and forth, and people argue, oh, we have a cooler year than the previous year, that climate change is a hoax. But really, our climate's a very complex system. Most of the energy is actually stored in the ocean. So when we see fluctuations in land temperatures, we can, simply have some local or larger effect like an El Nino or La Nina, which can create fluctuations in that. But really, most of the energy is being absorbed by our ocean. And as we get into, talking about heat and heat capacity, the heat capacity of the ocean is incredibly large when we compare it to the atmosphere. So, again, looking at land temperatures and temperature anomalies on land, obviously we're seeing a very clear upward trend. But even more frightening, the ocean, which is really the largest heat sink, has also been warming considerably. And really, the ocean creates a lag in our climate temperatures, our land temperatures, because it's absorbing a lot of heat. But when it reaches thermal equilibrium, the land temperatures are going to continue to go up, even if we don't do anything, even if we don't increase our carbon dioxide output. So again, clearly, we look at our current carbon dioxide levels. We are well over 400 parts per million. It doesn't sound very much, but if we compare that to the fact that up until the Industrial Revolution, we were well below 300 parts per million, that's a huge increase. That's a huge increase. And again, going back to previous data of climate, if we compare where our carbon dioxide levels are today to what our temperature should be for those carbon dioxide levels, we're going to see a huge increase in land temperatures as time goes by, as the systems come to equilibrium. What I mean by that is the ocean is still absorbing a lot of the energy. We're still having a large lag. So even if carbon dioxide levels stayed a little over 400 parts per million, our temperatures would continue to go up very significantly. Again, this is not evenly throughout the world, so sometimes it's difficult to convince people that's happening. But where we see the greatest temperature anomalies are in the Arctic. Okay, this is where we've had a very dramatic loss in snow cover. This leads to a decrease in albedo, which means we're absorbing even more energy at these high latitudes, and this affects climate change even faster. So obviously, the solution that's been presented is to reduce greenhouse gases to prevent the temperatures to continue to go up. But again, my understanding, most models tell us that our current temperatures today are really due to what our greenhouse levels were 30 years ago. That's how long it takes the land temperatures to catch up with the absorption of energy by the ocean and increase ocean temperatures. So what can we do? Well, obviously we're on a path that is going to continue with an increase in temperatures no matter what we do. So the sooner that we can reduce our carbon dioxide emissions, the better off we're going to be. Now, if we go back in time, our greatest source of energy was biomass, mainly burning wood. In fact, what's interesting in the Northeast is most of the forests that we see in the Northeast today are not the original forests. Most of the forests were actually wiped out in the Northeast because wood was converted into charcoal, and that was a huge source of energy. Today, many people still heat with wood. If wood is obtained by basically, culling out, the dead and diseased wood, this can, be beneficial. In fact, I do heat my house with wood. We've had a lot of, tree loss due to emerald ash borers around where I live, so I cut out a lot of the dead trees, and this allows newer trees to come in and replace them, reducing the amount of carbon in the atmosphere. I'm not really having a big impact, but by burning wood, burning essentially what is going to decay and release carbon dioxide, at least I'm not tapping into fossil fuels to heat my home. So wood, pretty good source of energy for quite a long time, 15 million joules per kilogram that we burn. And if it is harvested properly, it's essentially carbon neutral. Obviously, if we cut down forests as a source of energy, this would be devastating to the planet, because forests are great carbon sinks, and therefore, not properly harvesting the wood would have a negative effect. But today's economy requires so much more energy than wood could provide. So wood is really not the answer as a major source of energy. During the Industrial Revolution, coal became a huge source of energy. Obviously, at 30 to 33 million joules per kilogram, it's much more energy dense source than we received from wood. However, obviously, it has a very large carbon footprint. We get about 1 kilogram of carbon dioxide into the atmosphere for every kilowatt hour of energy that we typically produce. There are different types of coal. Coal is essentially wood that has been fossilized. Bituminous coal produces about 950 grams per kilowatt hour. That has more hydrogen in it. It's more hydrogen as a hydrocarbon source. Lignite coal and anthracite coal, of course, are more carbon proportionally, and thus have a larger carbon footprint. Now, coal has become cleaner. It's has been notorious for years because back when it was not being we weren't using techniques to clean up the emissions. It was giving off a tremendous amount of mercury, lead, arsenic. Believe it or not, it actually gives off even radioactive isotopes such as uranium that are trapped within the coal when we burn it. And scrubbers have done a very good job of removing this from the emissions, but they're still a major polluter in terms of introducing toxic elements, as well as nitrous oxides and sulfur dioxides in less clean power plants, which produce acid rain. So really, coal is identified as being one of the worst in terms of the fossil fuels in producing energy, and therefore everything should be done to reduce our reliance on coal. Petroleum's a little bit better, a little more energy dense, a little more hydrogen rich, about 44 to 48 million joules per kilogram that we burn, but it's not a whole lot better. The oil that we extract as traditional petroleum is actually cleaner than the stuff that we extract from the bitumen from the shale oil. But again, we're still about 0.88 kilograms for every kilowatt hour of energy that we use. So in terms of an improvement over its carbon footprint, over coal, it's better. Certainly, we would reduce our carbon footprint by replacing all our coal sources with petroleum, but it's not a whole lot better. It's not a solution to the problem. And again, if we're extracting this petroleum from tar sands or bituminous sands, we are almost up around where we were with coal, about 1 kilogram of carbon dioxide emitted into the atmosphere by all studies that were done per kilowatt hour. Now, this is going to be somewhat controversial because fracking has received a real negative, reputation. But natural gas is much lower in terms of its carbon footprint than either petroleum or coal. So if we can use natural gas as sort of a stopgap measure to replace coal and replace petroleum as a source of energy, we do reduce our carbon footprint because we're down to about 60% of the carbon footprint that we have from coal and from petroleum by burning natural gas. And again, fracking has a terrible reputation for polluting ground sources of water. As we improve the technology for fracking, maybe we can get around some of these problems. But from a pure carbon footprint standpoint, most of natural gas is methane, which means we've got 1 carbon for 4 hydrogen, and that's much richer hydrogen-wise than we had with petroleum, which are much longer, chains of hydrocarbons than these. More carbon for hydrogen there. But again, hydraulic fracturing, or what we call fracking, has received a pretty bad reputation for polluting wells, and certainly, polluting our water supply just to, prevent, climate change or reduce climate change, isn't a great trade-off. So, with better, regulations with fracking, it is a fairly new technology. Um, we can avoid, some of the worst problems that we've had with this technology. But again, burning natural gas is, you know, as far as carbon footprint goes, it is still an evil, but it is the lesser of the evils when we compare it to natural gas and coal. And when we consider the fact that petroleum shown here in red and coal shown here in gray provide most of our energy. Okay, nuclear and renewables are not being ramped up fast enough to replace them. Natural gas is a better alternative. I hate to say that. And it is a stopgap until we can um, improve the carbon footprint of these other sources of energy, ramping up solar, ramping up wind. Um, no matter how quickly we try to do it, it is just not going to, fill in those gaps, those energy needs that we need. Um, Ethanol has been proposed as another source of energy. Initially, it sounds like a great idea, ethanol. It's not a fossil fuel. We can use corn in this country to produce starches that can then be broken down with enzymes and then fermented. And suddenly we have ethyl alcohol, and we can use that to replace petroleum, especially for transportation. Here's the problem. Ethanol does two things. One, we're basically using food as a source of fuel. So we're going to have to replace the food that we lose from here with, other farmland, probably meaning that we need to, cut down more forests to bring land into agricultural production. And usually that means it's going to have a carbon footprint there. But corn is a terrible crop in terms of generating fuel from it. It needs a tremendous amount of fertilizer. Fertilizer has a huge carbon footprint. So really ethanol, via corn is not all that much better than simply distilling gasoline from petroleum and using that to power our transportation. So corn ethanol isn't great for reducing our carbon footprint. In other parts of the country, they can actually produce ethanol from sugarcane. Again, sugarcane is also notorious in terms of its pollution. It's hoped that someday that we can actually turn, believe it or not, switchgrass into ethanol, and this would be a great, a great reduction in our carbon footprint because unlike corn, it doesn't require massive amounts of fertilizer to grow. The problem is we're not there with the technology. Again, sugarcane has sugar in it. We can directly ferment that into ethanol. Starch, we can add enzymes to it to break down the starch molecule. Starch is just, sugar weakly bounded together. So, of course, it's not hard to break those sugar molecules apart and again, ferment them into ethanol using yeast. However, using things like switchgrass, which has been proposed, cellulose is very tightly bound, sugar molecules, and we don't have the enzymes that easily break them apart. Really, the technique to break them apart is chemically difficult, but also very energy intensive. So we're not there yet. And again, in terms of coming up with different carbon footprints of these different ethanol fuels, a lot of them aren't all that much better than petroleum, according to some studies. Some studies, and I have to be careful here because I'm not an expert on these studies, but different studies don't show that this path of producing ethanol from corn gets us to a smaller carbon footprint. Biodiesel is a little bit better, but again, you're converting, food stock into fuel. Ethically, that's difficult when so much of the world is food insecure. But biodiesel does a little bit better when we're getting these diesel substitutes from either soybean or from things like rapeseed. And again, biodiesel has a better carbon footprint, but we're still not to the point where we can say the carbon footprint is reduced. That's worth giving up this cropland for fuel. There have been a lot of work in turning algae into biodiesel. You look at some ponds during the summertime, they have this pond scum on top of them. Well, that actually is quite a few fatty acids, but as easy as it is to grow this algae on top of these ponds, doing this in farming situations has been quite difficult. So all of these technologies, in terms of using biomass to generate ethanol, using biology to generate different types of fatty acids, which can be converted into petroleum substitutes. Still the technology hasn't made it easy, economical, and produce a carbon footprint that is much better than what we're dealing with today. Hydrogen was proposed as a source of energy. Problem is there's no natural source of hydrogen where we can directly extract hydrogen from the ground or extract hydrogen from some other source. Hydrogen is typically used or typically produced through petroleum, which again has a large carbon footprint, or through electrolysis, which is very energy intensive. There has been some proposals to use nuclear energy to generate hydrogen, but again, hydrogen is not a primary fuel source, so that doesn't help us. Photovoltaics, solar energy, has been increasing almost exponentially as this becomes cheaper and cheaper and cheaper. But we have to be careful here because solar energy is not carbon neutral. There is a cost in terms of carbon footprint for producing solar panels. And solar panels generally only have a lifetime of 25 years to 30 years before their efficiency drops off too much. In terms of comparing them to coal, the numbers that I get put it to about 1/10 of the carbon footprint of coal, which is a great improvement, but again, not completely carbon neutral. And they do take up space, okay? Although we are installing photovoltaics at a record pace, again, when we compare solar to other sources of energy, it still only makes up a few, we're still in single digits in terms of the percentage of energy that it can provide us. And the worst part about it is it's intermittent. It only produces energy when the sun shines, because then it requires, battery storage, which also has a significant cost to produce. Wind's a little bit better. We see that, and this is getting better. Photovoltaics have a carbon footprint of about 1/10 of a kilogram of carbon dioxide per kilowatt hour produced. Wind is about 2% of that, but like the photovoltaics, what do you do with these windmills once they've outlived their useful lifespan? Some have proposed to create artificial reefs with them, but again, that can be expensive. They do have a a limited lifespan. They do impact the environment. They do kill birds. Again, it's balancing one impact with another impact. Geothermal, is basically getting heat, extracting heat from the ground and turning that into energy. Tends to be very localized. It tends to be very expensive. When there isn't a source of energy very close to the surface. But again, its carbon footprint is somewhere on par with photovoltaics. So now we go to saying, all right, here are our primary sources of energy. We have coal, large carbon footprint. Petroleum, also very large carbon footprint. Natural gas, better. Okay. Renewables, we are ramping up renewables, but it's going to take some time to bring them up to speed. That's the production. If we go on the other side, the consumption, the best that we can do in terms of reducing our carbon footprint is to be more economical, be more efficient, use less energy. And that's really the best way that we can reduce our own carbon footprint. So there's the source end of it, there is the consumption end of it. So now we're going to talk about the consumption end. Now, one thing that's being pushed on the consumption end is this idea of using a heat pump. And heat pumps are much more efficient in heating and cooling our home. And heating and cooling is a huge part of our carbon footprint, especially in the Northeast where it gets very cold, or in the northern Midwest. The idea here is the ground pretty much stays constant at about 50 degrees Fahrenheit if you dig down far enough. And in the summertime, if we can dump heat into the ground to cool our houses, it takes very, very little energy to do that. We can extract heat from the ground to heat our houses in the summertime. Sorry, wintertime. We could greatly reduce the impact of our carbon footprint. Now, I looked into geothermal heat pumps, and they're great. They do pay off after a while. But I will tell you, as a retired college professor, I have difficulty coming up with the money to justify, putting in such a system. And, every year I go through the numbers and it's too expensive for me, even with the government rebates. So I think if somebody's very conscientious and they have the capital to install these, it's great. If you're doing new construction, it's great. And of course, new construction, I would argue, is, gives you a huge carbon footprint just building a home to begin with. So if you're doing new construction, you can offset some of that carbon footprint by installing geothermal heat pump. But again, very expensive. Most people can't afford this. Oh, I should have put hydroelectric, there previously, but not a great place to put geothermal heat pumps. Should really have done that at the end. Just to wrap up production. Hydroelectric, low carbon footprint, devastating though to rivers. So the negative impact on river ecosystems has been, very significant. So, generally hydroelectric is frowned upon, even though it's low carbon footprint. Nuclear fission, very low carbon footprint when we compare it to coal. And again, everybody's worried about fission in terms of accidents happening, but really the safety record of nuclear fission in the United States is outstanding. And if you look at countries like France, which heavily rely on this, fission is great there. The problem with nuclear fission is it's expensive. Okay, in terms of building new power plants, it's hard to justify the cost of fission when solar and wind are just so much less expensive. However, fission can be very, very important for producing the base load, for producing, energy, just at constant rate, which can be consumed off the grid. The problem is people have been pushing. In my state, New York, they shut down Indian Point, which was a huge, huge mistake because it was providing clean, green energy. It did have some problems, but it was providing a base load, which has now been replaced by burning natural gas. Nuclear fusion, great idea. We'll go into this in later courses, but you know, there are no commercial fusion power plants. It is really the power of the future, but it has always been the power of the future. Back when I was in high school, decades ago, we were told it was, only a few decades off, maybe 10 years off, 20 years off. Now I've retired and, it's still 10 to 20 years into the future. So I'm not holding my breath on nuclear fusion. But again, that's the production end. Conservation is the other way to look at this problem. How can we reduce the energy consumption that we have so that we don't have to produce so much energy on the other end, where our energy system is very, very heavily carbon intensive? Well, if we look at, basically our energy consumption by sector, a large percentage of it is putting energy into the electrical grid, and this is going to get bigger and bigger as people switch to more EVs, as people switch to heat pumps and other sources of, I should say, other consumers of energy. This percentage is going to grow. Transportation is 20%, 28% in industry. It's about 21%, and then residential 7% and 4%. So really anything that we can do individually to reduce this is very, very important in terms of, again, reducing our carbon footprint. For the average American, our food supply makes up about 14% of our individual carbon footprint. Our transportation, 28%. Stuff you buy. Stop going to the dollar store and buying consumable, one and done stuff. Try to do reusable stuff if you want to reduce that. Heating and cooling, huge part of our carbon footprint. So, as an individual, I try not to get preachy with other people. I try to look at what am I doing? Am I being a hypocrite with my carbon footprint? And going through this, you look at your heating and cooling. What can I do to reduce this impact that I have? Maybe not heat our home so much in the winter, maybe not cool it so much in the summertime. Again, I've heated my home. I live on a farm. We have enough forest, where I can cut down dead trees, turn that into firewood, burn it in a low emission stove, and my heating impact is pretty much zero because that wood that I cut and I burn would basically decay and release carbon dioxide into the atmosphere anyway. On the cooling end, I've been trying to use cheap solar panels from Amazon and some other areas. I've actually bought some reused solar panels to run air conditioners off of an inverter. I have been looking into air source heat pumps. They're a lot less expensive than geothermal heat pumps. So I've been able to essentially bring this down pretty close to zero. And again, I live my lifestyle is such that I'm able to do that. In terms of stuff I buy, I try to not buy disposable stuff. Transportation, um, I was fortunate enough to buy an EV when, back in 2019, when dealerships were having a tough time selling them. I try to charge my EV as much off of, again, solar panels that I've bought. But again, I do rely a little bit on the grid for that end of the transportation. And in fact, even the EV that I have had a larger carbon footprint to produce than a regular internal combustion engine. With food, try to buy local, try to buy food that's locally produced. And I'm not a vegan, but if you are, your carbon footprint's much less than mine. So first of all, our carbon footprint is a very complicated thing to calculate. Land use, farm, if we are not vegetarians, the animals that we eat, I'm not a vegetarian. Um, all of these things will impact, uh, how even the food that we eat, uh, how large of carbon footprint that we have. And in terms of what we eat, you know, the more we eat, the more land use that we have to put into agriculture, um, the more methane that we might produce, especially if we're eating a lot of beef. Obviously, we have to feed animals if we're not just eating vegetables, and then processing, transportation, and retail. So when we look at all this and we look at our carbon footprint, again, just based on food, um, the food that we eat has a big impact on our carbon footprints, since about 14% of our carbon footprint comes from that. Now, as you look here, you can see I don't eat a lot of beef. I'm not a really fan of this stuff. I tend to eat more fish and looking for poultry. Okay, still larger carbon footprints, but again, I would love to be a vegetarian. I haven't been able to convince myself of doing that. I've tried it a few times. It hasn't worked for me. I'm sorry. But you can see eating more vegetables, getting more of your protein, your fat, your carbohydrates from vegetables has a much smaller carbon footprint. Here's a big thing: buying locally, because you know part of this is transportation and processing. The more you buy locally, the less your carbon footprint's going to be. But again, I hate to say it, I vegetarians and vegans, you have me beat in terms of a lower carbon footprint. Um, in terms of lighting your home, 6% of your footprint actually comes from lighting. And we've gotten away from incandescent bulbs, which are very, very inefficient up here in the red. We went to compact fluorescents, which are better efficient, lower carbon footprint, but they have mercury in them. So really, the switch to high intensity discharge lamps and to LEDs. Fortunately, metal halide have mercury in them too, but the switch to LEDs has had a big reduction in our carbon footprint in terms of lighting. LEDs are just so much better in terms of their efficiency. So, again, obviously, don't use lights when you're not in the room. Try to reduce, you know, uh, unnecessary lighting. Don't light up your house at night just because it looks nice. 6% of your footprint generally comes from lighting. Again, carbon footprint. I've retired. I'm doing some adjunct work now. So my carbon footprint from traveling is not as great. EVs do have a smaller carbon footprint than traditional internal combustion engines. But take a look at this. Hybrids can be a more economical alternative to regular gasoline and diesel vehicles. Their carbon footprint is significant, and we're starting to see that, especially with trucks, pickup trucks, which are used to tow things for a lot of small businesses. Um, you know, buying an EV, which can be $100,000 for an EV pickup truck, and have a huge carbon footprint to produce, you're actually better off buying a hybrid, um, which is much more efficient than petroleum car. And of course, commuting, if we can do so using a bus, if we could do so using a rail, that's a smaller carbon footprint. But in the United States, we notoriously have a bad um, public transportation infrastructure. So that's difficult to do. But again, EVs, highly controversial because, again, the carbon footprint to produce these is greater than that for a regular car. So for somebody who buys a new car every 3 to 5 years, you can have difficulty, justifying an EV. Okay. But if you hold on to these for a longer period of time, you can reduce your carbon footprint there. And it's a significant amount of how you contribute. Finally, heating systems in terms of carbon footprint. Um, Again, I'm looking into an air source heat pump. Uh, in terms of cooling and heating, uh, ground source would be better efficient wise, but air source, they're getting so much better. Um, I do burn wood during the winter time when the air source heat pumps aren't really very good. Uh, so hopefully I can get my carbon footprint reduced by going, air source and running off the solar panels. And again, because I'm knowledgeable enough, I can, create my own system where I can buy inexpensive photovoltaic cells, run them through an inverter, and power my air conditioner when it's sunny out and when it's really the hottest. Okay, sort of a hodgepodge. I apologize for that, but hopefully, um, I think this section, if it does anything, um, might inspire you to look at these figures yourself. I'm not an environmental engineer, so I would rely on people who are experts in this field of how you can reduce your carbon footprint. And when looking at you know I hate to say political um, you know political discussions on climate change, hopefully you do rely on the science behind this. And when we can have an honest discussion, I think that's when we can affect change. In terms of my opinion on this, I think we're going to not solve this problem, and we're going to continue to put it off into the future. And life is going to continue to become harder as climate changes. And unfortunately, I think the poorest uh, populations in the world are going to continue to suffer the most because of this. So, just my opinion.